morning, student. I am NV Krishna, Assistant Professor in CSC Department. I am handling the compiled design. In the last class, we have seen the SLR Parsing Table. Now we will see the construction of the SLR Parsing Table. Right? So, in the previous SLR method, we have used the SLR Parsing Table. Using that parsing table, we have performed the SLR parsing method. Now in this class, we will see the construction of SLR parsing table. Right? So here an LR0 item of a grammar G is a production of G, a dot at the some position of the right side. Here in this example, this is the production it is given. Now, there are 4 possible different LRJ items is possible. Dot at the middle, dot of the first one, of the second symbol, of the third symbol. The dot indicates that till that symbols are verified or it is passed. The status of passing of the production will be represented by this dot. So LRG items will have a dot on the right side of the production. The sets of LRG items will be states of action and go to table of SLR parser. So here the set of LRG items will be the states of action and go to table in the SLR parser. Here these LRG collections are used in the construction of SLR parsers. For every grammar, we add a new production. S1 dash give S. S1 dash S dash give S. So every grammar we add a new production. S dash gives S. As S dash is a new starting symbol. Right? So remember that for all the grammars in SLR parsing table, we add a new production. S dash gives S and S dash is a new starting symbol. If I is a set of LRGO items for grammar G, then closure of I is a set of LRGO constructed from I by the two rows. In the construction of the SLR parsing table, we use two words: closure operation, Goto operation. If we able to find the closure operation and Goto operation, then using them we construct the SLR parsing table. How to construct the closure of I? Here, initially, every LRG item in I is added to closure of I. Every LRG item in I is added to closure of I. If dot followed by variable, that is in closure of I, and beta gives gamma, B gives gamma is a production in G, then add this production into closure of I. We will apply this rule until no more new LRG items can be added to closure of I. First thing, all LRG items in I added to closure of I. Then A gives alpha dot B beta dot B. The B is a variable and B has a production in G. Then add that production to the closure of I. We apply this rule until no more new LRG items can be added to closure of I. Right? If dot is followed by variable, that variable productions also add to the closure of I. That's all. It will be repeated till no more new LRG items will be added to closure of file. E dash gives E, it is added. Then E gives E plus T, E gives T gives T into F. Here, these are the different productions of the grammar, right? This is the productions of the grammar. We added our new production here, right? E dash gives E. Then close of E dash is equal dot E. Dot E, so add E productions to here. So dot E, so add this E productions. Then dot T, so add T productions here, right? Dot F, so add this F productions here. Remember that if we understood this step, it may be repeated for many number of times, but it is easy to construct the closure of all productions. The first one, E dash gives E. So closure of E dash gives dot E. Closure of E dash gives dot E. Dot followed by a variable. Dot followed by variable. What is the variable? E. So add the E productions to here. Dot E dot T. Right? Then dot T already added E productions. So dot T. Dot followed by T. So add the T productions to here into closure file. Right? Dot T into F dot F. Dot T is already over. So we have to consider dot F. So dot F, so add F productions to the closure file. Right? Dot followed by terminal, dot followed by terminal so that we can stop. We will repeat till no more new productions be added. Otherwise, simply we consider here dot followed by terminal symbols as an end. Right? We will add all the productions which have dot followed by variable, and whenever the productions are dot followed by terminal, we can stop. Otherwise, we can say there is no more new productions to be added to this closure file. Right? Then Goto operation. Remember that closure operation, Goto operations are two main operations by which we can construct the SLR parsing table. Right? Now, what is a Goto operation? If I is a set of LRG items and X is a grammar symbol, it might be terminal or non-terminal, then Goto I comma X is defined as if this is the production in I dot X, right? Then every item in X dot will be in Goto I comma X, right? So dot X is there, right? Is it changing to X dot I on symbol X? Then every item in closure of A gives alpha X dot beta will be in Goto I comma X. Listen here. This is I is a set. I as this one. Now on symbol X, I is a initial closure set. I is a initial closure set. On symbol X will be go to a state closure of A gives alpha x dot beta. If beta is a terminal, simply we don't consider, we stop there. But beta is a variable, then we'll follow the rules of closure of production, right? And we'll complete the closure of I. We'll fill all the productions to this closure of I. So it is clear, if A gives alpha dot x beta in I, then on symbol x, it will move from I to j. What is a j? J is a closure of this production. A gives alpha x dot beta. So dot x is moved to x dot. Right? Here, our initial I is here. Now, this I has some productions, right? These productions will have a dot. Dot might be followed by a variable at terminal. Then this closure I will have a transactions on the Goto operation for each variable and terminal. So there will be a transition on E, on T, on F, on right parenthesis, on ID. Right? So on E, on T, on F, on the left parenthesis, on ID. Right? So dot followed by symbol will have a Goto operation on that symbol. So I will have a Goto operation on these symbols E, T, F, left parenthesis, ID. Now, what will be the new closure of I? So here x alpha x dot b. So dot e. So we have to consider e dot e. So we consider e dot. Dot followed by terminal. So we won't add a new more productions. Right? Simply dot followed by terminal. Simply we stop. Right? Then I comma t. Right? So this is the one t production. Dot t. So it will be t dot. Next, here it is dot t into f will become as t dot into f. T dot into multiplication f. Right? So I comma t. Right? I comma e, then I comma t. So dot t has become t dot. Dot t into f become t dot multiplication f. Since in these two, dot is followed by terminal, we are not adding any more productions. Then I on f. Here there is only one production with dot f. Now it become as f dot. Then left parenthesis. This is a left parenthesis. Dot left parenthesis now become as left parenthesis dot. Dot left parenthesis now become as left parenthesis dot. Since dot followed by e, add new production e productions. Dot followed by t, so add t productions. Dot followed by f, add f productions. Dot is followed by terminals, and there are no more new productions to be added. Then the completion of the closure of I. Listen here. Dot left parenthesis became as left parenthesis dot. But what is resulting? It is resulting dot e. So add e productions. But what is happening? Dot followed by a non-terminal t. So add t productions. Then dot followed by f. So add f productions. Right? So it will be continued till no more new productions to be added. Go to I comma id, right? Which results fq's id dot, right? It gives f I comma id. Simply id dot id will be coming as id dot. This is for I group, right? This is for the single group resulting to 1, 2, 3, 4, 5 options, right? We have to complete this till all the productions end with dot. In a grammar, if there are 10 productions, all the 10 productions should end with dot. If there are 5 productions in the grammar, then all the 5 productions should end with dot. Till that, we have to repeat. This is only for the first group, we are I not this one we have considered. Now we'll see here, right? Construction of the canonical LR zero collections. Here we will continue this one to find the closure of productions, and we apply Goto on the closure. It will result in new closure productions and will repeat till that there are no more closure productions and there are no more Goto productions, Goto operations. Right? Goto function is a DF on the sets in C. Right? So we consider the first closure set and we'll find Goto operations on that one. Will result in new closure sets. Then we apply Goto operations on the new closure operations and it will be continued till there are no more Goto operations and no more new closure operations. Now we'll see. Here, till now, we have considered a I naught closure. We have considered I naught. On E, we have done the closure one, that is we considering as I1. On T as I2. On F, it is I3. On left bands is I4. On ID is I5. Listen here. Here in the previous slide we have seen, right? This is the we considering as I naught. This I naught resulting on E Goto operation, T Goto operation, F Goto operation, left hands is Goto operation, then ID. This we are representing here as I1, I2, I3, I4, I5. Now, what is I1 we have? Here, this is I1. This I1 has dot end, so no need for Goto operation. But here it is plus. So what is its result? E gives E plus dot T. Dot T. If it is T, then add T productions. Then add T gives dot T into F and T gives dot F. Right? Then what is F? Add F productions. Pans C and F gives pans is I. So that will be the I6. Right? So I6 will be here I'm writing. So it will be the E gives E plus dot T. So write T productions dot T into F dot F. F equal to Francis E. Then F equal to dot ID. So this is I6. This I6 dot T. So on T it will be the I9. On F, on T, right? On F it will be the I3. On left branches it goes to I4. On ID it goes to I5. What ID? On ID is giving F gives IT dot. What is this one? It is nothing but I5. We have the production, same production in I5. So we won't create a new closer ID. Simply we connect to the previous one. So dot E. So it will result to the same I4. Look at I4. Same. Dot Francis as Francis E. Then so add E productions. Then add T productions. Then add F productions. And continue. Right? This already that set is there. So we connect to I4. Right? So we connect to I4. On F, already I0 on F giving I3, which is the same, so we'll match to this one. But on T, it is giving, what is it giving? E gives E plus T dot. Then E gives, T gives T multiplication. T dot multiplication F. So this is I9. So this I9 has multiplication. So on multiplication, what it is gives? T gives T multiplication dot F. This one nothing but I7. What is the F productions? We had dot Francis E. F gives dot ID. So that is nothing but I7. Right? So because that set already we have. The set already we have. So we represent the same. Right? I7. So our first I1, I6, I9, I9 going to I7. So I3, I4, 5 over. Then I2 on multiplication will be the same. So what is I7? This is a I7. So what is T gives T into F? So F gives dot Francis E. F gives dot ID. Right? So here dot F. So I10 is T gives T into F dot. On Francis, it gives the same set of I4. Because dot E will result Francis, left Francis dot E. So add E productions, dot T, add T productions, dot T, add T productions, and dot F. So add F productions. It will be continued. Right? Then this is I7. Right? Now here this is I10. This is I9. This is I7. Okay? Then here I4. I4 on E. What will it give? This is I1, I2, I3, I4 dot E. So here these productions are considered. Right? This is a I4. Right? Right? This is a I4. Dot E gives E dot. Right? Dot E gives E dot. Right? I4. Here this is a I4 on E giving. On E giving. Here I8. So what are the things? F gives parenthesis E dot, like parenthesis, that is a one. Then E gives dot E as E dot. Any other protections we have? No. Right? E gives E dot plus T. Right? This is the two protections that we have to consider. Right? Here E gives E dot plus T. This is I8. So I8 on, like parenthesis I11. So it will be the FQs parenthesis E dot. Then here plus sign. Plus sign will be the I6. Right? We'll get the same protections. Then here I4 will be get on TF minus I2, I3, I4 only. On ID it is I5 only. There are no more new closure sets. So here once again I am writing here. So this is our I naught. So it is I naught. So this is I naught. So right here the first production, what we have written here, E dash Q's dot E. E dash Q's dot E. So E, right? E productions. E dot, right? Dot E. So E productions. E plus T. Right? Look at here. Dot E. So right, E productions. Right? E gives dot T. So dot T, right? T productions. T good T into F. Right? T into F. Right? T into F. T gives dot F. F gives parenthesis dot E. F gives dot ID. So this is our I naught group. So I naught on E, right? I naught on E, that is I1. So what is I1 here? E dash gives E dot, E gives E dot plus T. This is I1. Then I2 on T. So what is the transition tree? E gives T dot, right? Then T gives T dot into F. This is I2. Then I3 on F, right? On F. T gives F dot, right? T gives F dot, right? Same protections we are writing here. This is a I1, I2, I3, I4 that previously considered. Now we are writing as T gives F dot. Right? Is it clear? This is I3. I4 passes. If passes, what is I4 here? FQs dot E. So add E productions dot E plus T. E gives T. T gives T. T into F. T gives F. F gives passes E. F gives I. So this is this I4. Then what is I5? I5 simply FQs ID dot. So in this PPT only I have written I0, that I0 on these symbols E, this is I1, on T, this is I2, on F, it is I3, then on left balance is I4, this is I4, on ID, it is I5. Now I1 on plus, here dot plus has become as plus dot. Dot T, so add T productions, right? Add T productions. Dot F, so add F productions. Listen here once again. I am repeating, writing all the steps from the I0. Okay, so we have written I0. We are considering its Goto operations on the variables and terminals. It is giving I1, I2, I3, I4, I5. Then we are considering I1. I1 dot, it is end in the first one, dot followed by plus. So there is a plus, a Goto on plus, which is I6. So this is the I6. Here, what are the symbols of the dot? T, F, right? T, F, left balance is ID. So here, on T is going T dot into F, that is I9. On F, it is giving the same set of I7, right? On F, it is giving same set. On F, it is giving even I3. On left balance is, it's giving the same set. If we consider this one, F gives, right? Left balance is dot E, right? Then dot, so add E productions. Then add T production. Then add same I4. ID. F gives dot ID, giving F gives ID dot. Same closer sets is giving, so we are writing the same numbers, right? Then I9 dot N dot multiplication. So on multiplication, T multiplication dot F. T multiplication dot F will be the same. So I7. Because we are getting the same closer set. So I7. Then these are already included. Then I2. I2 dot followed by F multiplication. So on multiplication, it gives I7. I7 dot F. Dot F means T into F dot. This is the item. T into F dot. Dot F become as F dot. That is item. Pan dot left balances means same as here. So we are writing I4. Dot ID. ID dot. Same I5. Then here dot end. So no more Goto operations. Then I4 on E. So it gives E dot balances. Balances, left balances, E dot right balances. Right? E gives E into E dot plus T. That is a IT. that I8 group. Now, here, what are the terminals we have? Right balances and left side. Right balances and left side. All right balances going to here. This is I11 dot plus. It giving the same set dot plus this I6. So it will be the I6. What is here? E gives E dot plus T. What is the I6? So we are writing I6. Then I4 on T will get the same set I2. On F, same set I3. On left balance is I4, same set. On ID, I5. So we are rewriting once again all these groups. We are getting the same groups. There are no more Goto operations and closure operations. So finally, in this DFA of Goto function, we have 11 states. How many closures we have? I0 to I11. So they will be in the SLR parsing table. In the SLR parsing table, they will be 11 states. Right? Now we'll see how to construct that table from this diagram. Here, to construct that one, we need only the follow operations. We have first and follow. Previously in the top down we have seen first and follow. Just we need follow operations here once again. So here these all the sets once again we have written. I0, I1, I2, I3, I4, then I6, I9, then I11, I10, I8. So all the sets, closer sets, all the closer sets I0 to I11 we have written. Right? So here we have written on the diagram, but here it is a clear picture of all the sets. Right? Just you can draw the here on E, on T, on F, on left balances, on ID. Here on plus sign. Right? Here on T. Right? Here on T. It will have other Goto operations on F, on left balances, on ID. So all are we can represent here once again. Right? So simply we can say T is over, right? On F, it is I3. Right? I3. On balance is I4. ID is I5. This is the set. We got this I3, I4, I5. Right? You can write the same Goto operations in this closure also. Right? So better add all the closure and Goto in the single diagram. So we can avoid confusion. Right? Then how to construct the SLR parsing table. The first step, find or construct all the canonical collection of closure sets. First step, construct all the canonical collection of the closure sets. So find this I0 to In, canonical collection of sets of LR0 items. I0 to IN. Then create the parsing action table as follows. We have said there is a go to and action. There are two parts in the table. In the SLR parsing table, there are two parts. One is action, another one is go to. So, second step, constructing the go to action table. This action table consists terminals as the column headers. Terminals are the column headers. Right? A is a terminal. Here it is in I. Go to I on A go to J. I on A going to Z. Then action I comma A is shift J. Listen here. Close set I on go to operation symbol A going to J set. I on terminal symbol A going to J set. Simply write I row A column. I row A column. Right? Shift J. S J. Is it clear? It is main important one. If A is a terminal, I on A terminal going to J set, then we write action I comma A as shift J. Then second, here dot at the end of the production. Dot at the end of the production. Dot at the end of the production. Then action I comma A is reduce the production number A gives alpha. For all A belongs to follow of A. For all belongs to follow of A. Right? So here this action I comma A is reduce A comma alpha. What is A? A in follow of A. If the dot end of the production, then consider follow of A. It has some terminal symbols. In the terminal columns, write reduce A comma A gives alpha. Reduce the production number, A gives alpha. Where A is not the starting symbol. A naught should be S dash. If dot end for the first production, simply we write action I comma dollar sign is accept. If S dash gives S dot in some I set, then action I comma dollar is simply accept. Okay. Here action I comma dollar sign. So here S dash gives S dot. It is a special production, right? Since it is a special production, we write action I comma dollar is accept. I comma dollar is accept. Is it clear? These are the action table will contain shift J, reduce some production number, or accept. If any conflict actions generated by these rules, the gamma is not SLR1. So any conflicts, any cell having double entries, simply it is not SLR1 gamma. Next, third step, go to. Right? For all the non-terminals, we consider go to table. For all terminals, we consider action table. For all non-terminals, we consider go to table. So, go to I on A is Ij. Then we write I comma A is J in the go to table. This is go to operation. This is operation. This Goto operation saying that I on A go to Ij. So simply we write this go to table. This is go to table. In this go to table, we write I comma capital A equal to same. So here all entries not defined by 2 and 3 are errors. Right? Initial state of parser contains S dash Q's doctors. So here these are the 5 steps by which we construct the SLR parsing table. Listen here. First step, construct all the closure groups I0 to IN. Then for all the terminal symbols, we write shift J as reduce some production number by if the dot at the end. If the dot at the end, we consider the follow of A, we write A reduce A gives alpha in all the terminal symbols. If it is a special production, we write exit. Then if I on A giving J in Goto operation, simply we write Goto table I comma A as simply J. Listen here. So this will help in writing the SLR parsing table. So because it has the all the Goto operations in the table. Now this is the I naught. Okay. Now come to this one. I naught on E going 1, on T going 2, on F going 3, on left panses it is I4, on ID is I5. Right? These 3 are non-terminals variables. Here these 2 are terminals. So it will be S5, S4, this is 3, this is 2, this is 1. These 3 are in Goto. These 2 are in action. Right? First one E. In E we are writing 1. In T we are writing 2. F we are writing 3. Right? So simply this ETF resulting 1, 2, 3 we write simply 1, 2, 3. Right? Then we have the terminals. What are the terminals? I4 and I5. Right? So we write S4 and S5. In left panels S4. In ID we write S5. So our I0 group is over. Right? Now I1. What is I1? Dot end. Dot end. If dot end, what we have to consider? Check it is a special production or normal production. If it is a special production, according to this one, simply action I comma dollar is accept. Simply accept. Then what is another one we have? On plus going to I6. I1 on plus going to I6. I1 on plus going to I6. Right? Simply in plus sign, right? S6. Right? Then I2. What is I2 here? This is I2. I2 here dot end. Dot end. Right? Simply we consider follow of E. In the follow of E, we write production number here. Right? In the follow of E, write reduce the production number 2. Then one more we have here I2 on multiplication going I7. Right? I2 2 on multiplication S7. Dot at the end for the second production. So follow of E considered. In that follow of E terminals, we have written this R2 production in all the follow of E. For multiplication is going to 7. So we have written S7. Next I3. What is I3? Dot end. Right? Dot end. What is the follow of T? In the follow of T, we write R4. In the follow of T, we write R4. Then I4. Right? Here, set 4 on variables ETF is giving 8, 2 and 3. On terminals is giving 4 and 5. Right? 8, 2, 3 on terminals 4 and 5. What is I5? I5 F equal to ID dot. So write this production in follow of V. Follow of F. The follow of F we have considering. In that we have write reduction R6. Then I6. What is I6 we have? I6 on T and F going 9 and 3. On terminals left and right is going 4 and 5. There are 4 Goto operations. Right? It has 4 Goto operations. Right? 1, 2. On terminal symbols, it is S4 and S5. On T and F, it is 9 and 3. Right? From these DFA of Goto functions, we are writing this 9 and 3. Right? Then I7. Set 7. On variable, it is 10. Terminals 4 and 5. Right? On variable, it is F, 10, it is S4 and S5. Then I8. Here, it is the I8. I8, this is the I8. On terminal symbols, it is going I11 and I6. Right? Simply S11, S6. Then I9. What is I9? This is I9. Dot and for one production. And another one we have here. Goto. So on multiplication it is S7. So dot end. For the dot end production, we consider follow of E. And we write this production in all the follow of E terminals. And on multiplication is going to I7. Same thing we write here. I7 and for follow of E we have written this one. We are considering follow of E. In that one we are writing these symbols. Right? For dot is the end of the production. Dot at the end of production. For that, we considering the follow of the variable. In that terminal symbols, in that follow terminal symbols, we writing all1, all1 and all1. Right? So here fall of E, fall of T, fall of F we have to consider. In the terminal columns we have to write reduced operations. Then what is next? I10. I10 dot end. Right? Dot end. Consider fall of T. Right? Right? Then I11 dot end. Dot end. So consider follow of F. So write R5. So this is the procedure by constructing the canonical closure sets I0 to In and find the Goto operations. Then using that, if it is a non-terminal, we write in the action table. If it is a terminal symbol, we write in the Goto table. If dot end at the special production, we write as an accept. If dot end at the other productions, we consider follow of the variables, and in that particular non-terminal columns, we write this direction of the productions. Right? So here reduce R1. R indicate reduce the production number 6, reduce production number 1, reduce production number 3, reduce production number 5. Then S5 form shift and sim state, the next state 5. Right? So this is the construction of the SLR parsing table. So in the SLR method, in the last class, we have seen how to use this SLR parsing table to perform the parsing method. Now in this today class, we have discussed how to construct SLR parsing table. So by this, I am closing this class. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.